Hi everyone! I'm back streaming today, so yay! So happy about being back and being, again on Twitch. Just a little bit of a note: I'm not going to stream next Thursday, so this Thursday. So I'm going to be traveling and meeting some platformatic users. So I'm very happy about it. And I'm very happy to have you all back here. I am a little bit late, so I'm going to start doing some of the setup while we chat. So here we go. So we have this, and I need. Do you like the music? Right? We need to get the music going. So here we go. Let's set up the music, and we need the music because otherwise things are going to be a little bit boring, right? Do you like it? Do you like when there is music or not? Hopefully, yes. So, and then we go to soundtrack. Here we go. Let's set it up. And here it is. I can hear it. So hopefully you can hear it too. Hello. And then we go in Twitch. Then I'm going to set things up. Sorry about this. I'm a bit late, and I said I will be streaming today. So, hey, what are we doing today? So this is a good question. So what would you want me to do today? This is a question for you. So, question for you. I know what we will be doing, but what do you think we will be doing? I know, right? A world of possibilities. I know. So, okay, I am going to finish setting up, and here we go. Just a second, and I need all the bits. I am still finishing my setup today, a little bit late than usual, unfortunately. Why this is not? Okay, yeah, here we go. One, it's here, and the other window. And here we go. Okay. Okay. I have all the things set up on my end and ready to go. So what would you want to, did you decide what you want me to do today? Huh. So, okay, let's go back to, let's see what we had left to do on the Unscalable Queue System. Okay, so let's go to Platformatic, Unscalable Queue System. Yeah. If you have something specific that you want me to do, please let me know. Okay. Oh, wait a second. I actually needed to do something that I didn't like last time. We had a little bit of a glitch, so I'm just going to plug in my network card. Hopefully, it will help out. So if we have a network glitch, having plugged in internet will probably be helpful instead of Wi-Fi. So so we had a PR open here for the test refactoring, okay, and that we didn't finish, and then I did a mistake. Sorry, yeah, I made a mistake, big mistake. I started parallels. So oh yes. So here, so what is this? So it's the outbox pattern or a queue. So basically, after you can create a queue, you can put message in the queue, and the queue will just take care of sending it to the target server. And if it doesn't happen or there is a 500 error, it retries it. And right now we're just using a SQLite database for it. And yeah, essentially that's it. That's what it does, and it's written kind of in this diagram in the README. So hopefully you can get it. So here it is, and yay! So this is the Unscalable Queue System. Okay, So, and we are using Platformatic to build it. So let's see how it goes. So next, what's up here? And we had we had an open PR, but there was like I can land this PR now. I think it's good enough at this point. Let's land it. We opened it just last week and landed. Okay, and then we have another branch open that I haven't finished. We haven't finished working on it yet, which is transactions. So that's what we would do. So okay, and I need to start my automatic scene switcher. Here we go. Start. Here we go. Yay, git checkout main. Okay. Git checkout. Okay, yeah. npmi. Yee, amazing, geez. Oh, I probably need to do a tweet about this session, to be honest. So let's do a tweet. And look, we can do it from buffer. We can do a tweet. Okay, let's go a tweet. Let's go do a tweet if it opens up, because you know Twitter might be down. And I can do I'm live on Twitch TV Matteo Collina. Here we go. Okay, and then we are also posting on Mastodon, and here we go. Okay, cool. So we have posted stuff and so on. So we were implementing transactions last time. So git checkout transactions, git pull, git rebase main, git diff main. Let's see what we did. So we have wrapped everything in a transaction, but as far as I recall, this was not working last time, but it should be now, I think. The fundamental reason is that last time, in fact, it's working. Oh, there is a coverage error here. So the problem is that last time didn't work because we had a problem with the SQLite management of reentrant transactions. So in SQLite, you can't have reentrant transactions. So if you go in here, you see there is fixed next transaction support in insert one. We did this in last Monday's stream to avoid the creation of a new transaction if you were already in one inside Platformatic itself. It's cool, right? This was actually a simple fix. So basically, if we had a transaction, we would, otherwise we wouldn't. So cool. But going back in the code, we have, just a second, let me check something. Okay. And we are back in here. Great. Okay, so what we do now is that we have a problem of 3 lines that are not being managed, that are not covered by our okay, here we are passing the transaction. So 120. It's these blocks. It's those 3 lines, right? I think so. Yeah, 108, 120 is these 3 lines. So here we really, I would just not test them, to be honest. So I would just do Istanbul, ignore next, and forget about the problem. Why? Well, I don't want to test transactions. So I don't want to cause a transaction error or I have any problem with it. Oh, yeah. Sorry. And yeah, yeah. But this specific case, it seems that a try catch is good enough. Okay. And I look, how like I don't know exactly how this would fail. But we need a try catch here, otherwise we don't. Without this try catch, is not going to work. So let me see. Just instead of doing this try catch here, who is calling execute? So I might just not put it here. Yeah. Okay. Here. And okay, it's here. You see. So the problem here is this one that we need. Okay. You probably can see this. Okay. The problem is as this line 138. So here you can see that it's actually scheduling itself. And if there is something, which is down here, look, actually what will be best is we are not handling this error right now, but we should. Cool. This is actually even better. Way better. So it basically, we've just basically said, well, if this crashes, it crashes. And that's it. Oh, yeah, I made a mess. How is this finishing? Yeah, okay. Seems correct. Oh. Made a mess. Yay. Of course, you know. And I made a mess with the indentation and everything, I think. Yeah, this is not correct. We are kind of missing a message here. Okay, here it's correct, but then we need to click and close the prompt. Yeah. Yeah. Okay. Yeah, seems about correct. Hello, I'm hello Mateo Nunez. How are you doing? Welcome. Okay. We fix our transaction support, or better, we add the transaction support. We're not dealing with errors. So seems about good. Cool. Okay. Go. Git push dash dash force. Let's force push. Do you like force pushing, folks? I love force pushing. Yeah, I'm still working on this crap. Yep. So you should be familiar with the code at this point. So here we go. Let's see if there is something more here to be done. Oh, we need to add the transaction to libcron. Okay. So here we need to add the transaction. Okay. Args, but it's already doing the transaction. So it's, yeah, it's already added. Naturally. I think. Or no. Actually, no. So I need to add it. Okay. Okay. App, platform. Okay, let's do const db. Yeah. Then I need dbtx. Actually, no. Function run in transaction. Okay, async. Now we take all this code. Okay, we move it inside this closure. Okay, and then we do if argstx runs in transaction, else return, and we want to await it, running transaction. Okay, and here we have the x, and we do okay, we pass this thing in and we just do dx. Okay, so basically what we've done is we have extracted the previous code, put it in a closure called running transaction, and then put it behind a few ifs, so that if we already have a transaction, we are not running it. Otherwise, we are wrapping it inside the transaction. Note that this is an async function, and we are also awaiting it here. And the reason is, well, do I need it? No, I don't think I do. I just need to just do that. Okay, I can just avoid it. Okay, so because it's an async function, I just don't need to have defined the external one as a sync, so I can save a few promise and microticks. So give me a little bit of a perf boost, but maybe. So okay, let's see if this works. Oh yeah. Ooh. Okay. Hello, hi, Digrammatico. Cool, nice handle. Okay. Maybe it's passing, maybe it's not. Cron is still not passed, so I'm a little bit scared that it will never pass at this point. It's not passing. I made a mess. No! It's not passing. What did I mess? It's not committing. It's not going anything. It's not going anywhere. So yeah, I don't need this, to be honest. Oh, yeah. This, yes. Let's put a console error. Hi, folks. Hi, Augustine. Thank you for joining. So this is cold. Okay. Here and there. Oh, yes. We need to put the TX even here. Seems passing now. Okay, found the bug. Found the bug. Here we go. Okay. Oh, wow. We have one line that's not ready. Line 14. Yeah. That's okay. I'm just going to... Look, I'm just not even bothering. This will fail. Might fail. If safe is called. This is not the case right now. Okay, you need from time to time make some compromises, right? Cool. Okay. You know, it's 100% code coverage. Who would have guessed that? So, and with this, we have solved all the to-dos. Okay. Okay. It's passing. Okay. Git push. Okay. Very happy. Let's open up our PR. And look, it's passed and it's been also deployed. So happy days. Here we go. It's CI, it's running. Cool. So today I was on a call planning the next edition of NodeConf. So we're going to announce dates soon. What's your travel plan, folks? Are you going to conferences or not? I'm going to see you. Was going to a call lately, and look. So it's pretty cool, right? We're going back in Kilkenny next year. So very excited about it, to be honest. Would you come to NodeConf? If you want to know what conferences I am going to, you can get them into, you go to my newsletter and yay, I was there at this point in time. So if you go to my newsletter, you can go and see them here. Probably this was not the last one, but if you go into, in some of them, I have, I think I added this in this one. In this one, you see that I have upcoming events. So I'm going to be at Open Source Day, CCCS, JS Day, Node Congress, and Vancouver, and so on. And this is Adventures Not Live Not Dive is my newsletter. Cool. Oh, so are you in Italy, Reno drummer? Well, if you are in Italy, you can come to Open Source Day in Florence or JS Day in Verona. Would you come? Hi, Talevo. Cool. It's nice. I'm doing a workshop on that JS Day, right? If you don't know, here we have a lot of nice speakers, by the way. I know a few of them. There is Luca, it's a friend. Michele, I hired him at the time, and Tejas is another friend of mine. Luciano, here we go. Fabio, I know a good chunk of them, not all of them. Quite a few new faces too, so I'm very happy. I don't know why those conferences don't happen in India. If they can happen in Italy, they can happen in India too. You have way more developers in India than in Italy, folks. So you can definitely make that happen. It's pretty nice conference, by the way. Cool. Okay, so we have pushed this. Test has passed. Yeah, landed. Great. Amazing. So what's left in my README? Okay. Oh, we need probably to do some more refactoring on the test. So there's investigate remaining to-dos. So, okay. So the to-dos are being done. Okay, so this is done. So git st, git add dot, to-dos are done. What is madness? It's what is full of madness? Sorry, the video at Laravel, India. Are you using Laravel, folks? Are there some few folks? Oh, made a mistake. Yeah. Need to push it again. Oh, what do you like Platformatic? Have you checked it out? It will probably simplify quite a little bit of your code and remove the need to use Laravel. You just use Node. Okay. So, okay, and then the refactor test, so that there is little repetition. Okay, let me see where we are at with that. Here, this is simple. Okay. Yeah, I see that there is a little bit of repetition. Okay. Yay! Check it out. Okay, it's there is a lot of things happening here, and I think there will be a lot of stuff that will benefit you. So, okay, just trying to understand how much of this I can reuse. And I want to simplify, but to be honest, look, I would not simplify this any further. I have already extracted the server, the admin secrets. I would just keep them as is, to be honest. I think this is enough. Okay. And Okay. And then the thing is add a message limit. Yay! Thank you. I'm so happy. Feel free to get inspired more, to be honest. Cool. So we have here, we have done the refactoring and add a message limit. So we want to limit the size of the message that we're going to send. Why? Because we don't fill the database. Oh, I'm so cool. Why I'm so cool? Because I have a fancy platformatic.dev t-shirt. Look at this. We made this special edition of t-shirt for when we went to halfstack.js in London. And look, it has the London eye inside outside our P. It's really cool, right? Sorry, I loved it. Thank you. So, where are we? Add a message limit. How do we add a message limit here? So, first of all, we want to write a test. Okay, and to add a test, we copy a test. That's what I would do. And then I call it test message limit. So what I would do is I would probably store the message limit in the queue. So when you create a queue, you define the message limit for that specific queue. Why you would say look. Because I think there should be a generic timeout, a generic configuration value like global maximum or something, but I will probably just cable it in at maybe 1 megabyte. And then, well, maybe that's even enough. Like I would not even need, I would just put it at 1 megabyte. It's just very simple. Safety here, just 1 megabyte. Okay. That's just 1 megabyte. So I'm not going to be this called a target. And I'm creating the queue. I'm creating the message, okay? And in order to send the message, this is the message, okay? And this is the body of my body. It's, so I don't need this. This is my message, okay? And I need something different here. So both buffer, a lock, and 1 megabyte. Does that? No. So let's say this is 1 kilobyte. Then we need to multiply it by +1. Okay. And I am initializing it with A and converting it to UTF-8. Okay. And then I am adding a few bits. So here I need to start. This needs to be a JSON. So okay. Okay. Cool. And these should not be accepted. So this should not equal save message undefined. Well, null actually. Should be null. Then, and I want an error here. Let's put a console log errors and then see what errors come out, and then I'll copy it. So my friend Tommaso was asking this question: Is there the possibility to set the timeout per endpoint? I think it's already as the timeout per endpoint when we started. So let me see. So in here, let's start the queue. So okay. And I can open it up. Okay, and I can open graphical. And as usual, when I open this graphical, it takes forever for some reason. Then I need to refresh it. I don't know. I just make some mistakes somewhere. Why this graphical is not loading? What's the problem? Oh, unpackage because, yeah, whatever. Cool. So, okay, let's close it. I just need to, okay. Okay, so here we have mutation and we have save a queue. And when we create the queue, we can specify max retries. Oh, we don't actually. No, we don't. You're right. We can add that. So here on the queue input, we have, well, we can control it with the number of maximum retries. So it's not, you don't have a maximum timeout, but you have the maximum number of retries that you can do, which in essence is the maximum number of timeout, to be honest, because each we retry using a Fibonacci algorithm. So a backoff algorithm, I think it's the backoff, it's, yeah, it's just the power of 2. Yeah, so yeah, I think you can more or less get that, but we can possibly put in also a maximum timeout or something. I don't know. Might be cool. I'm actually creating an issue on this, and default is 60 seconds. Probably try for production. Well, I don't know, right? Because why should be too high for production? Okay, I would probably, this is a value that if it's a queue, like this is for a queue, right? It's not for real-time code. If I need to do a real-time call, I just do a real-time call. Yeah, depends on the endpoint. True, that depends on the endpoint as everything. But you can put the retries to 1 and that's it, and just do 1 and then it just do, or make it 2, whatever, and then there's very little. Like if you put it to 2, it stays very little and it's fine, right? So how many times would you, like if it's waiting for 2 seconds or 5 seconds or 10 seconds, how many times it should retry to? So here, where we go? It's on the executor. Yeah. No, there is not a maximum timeout per se. Like it's just the maximum amount of retries, essentially. So here I'm creating a new issue. Max timeout property to the queue. Sorry, I don't understand, Tommaso. So you are expecting if the timeout is reached, the call is considered as key. Oh, so you're talking about the timeout of the connection of the call. Oh, yes. Okay, now I understand. Sorry, I didn't understood what you were saying. Yes. Okay. So yeah, let me add an issue. So add max timeout property to the queue to check the maximum wait for a response. We should add a timeout to consider a target service KO and then start the retry mechanism. There we go. This is even a good first issue, so going to be fun. Yay! Okay. So we were talking about adding a message limit. Okay. So, and we just want to have a generic message limit of probably of 1 megabyte, essentially. And plug in message. Okay. Oh, good question. How is it going, the fastest thing? Well, we are currently waiting for the Astro team to implement what we need. Like, essentially, all the work that we did was based on API speculation. So we're just using internals to get the data that we need to get to create the actual extra stuff. And yeah, it's waiting on them to do their bits. But if it did, it will just be magical. So finger crossed, we'll get something soon. So here we have, I think, message. Is it message? No, it's the other's body. Okay. So, haha, yeah, that was fun. That was fun. So, okay. Let's print this. Let's see what this is, because I have no clue, really. Okay. Yeah, target is not defined. Yeah. Okay. 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 T is not defined. 413. Whoa. Equal. It's a request body limit to the HTTP request. So that's what we are implementing. Ooh, 459. Yeah, its request body is too large. It's already implemented. Where did I implement this thing? Sorry, I'm wondering. I'm wondering what I did. This is how many are. These are 4. Okay. Ha! Okay. Amazing. Okay, so with GraphQL, things are safe. Okay. But what if we use REST? Because I can create this same thing with REST, right? So I can do queue QAD, okay, message, post, and I need to post headers, JSON stringify. Ooh. Ha! That's Fastify. Amazing. I love it. Like, I don't have to do anything. Oh, you made me so happy. But I probably need to make it configurable in Platformatic, right? Because I don't think I am. I am making it configurable in Platformatic. So, yeah, that's perfect. Let me check. So where is the server? This is course, massive course definition server. Yeah, it's not here. Well, it will pass through, but it's not here. Yeah, no, but I want to check the large request body. So I just need to provide on the server that information on Fastify. So let's just do that instead. And where is it? No, I wanted the server here, the factory, and the factory. And yeah, yeah, well, I just want to provide some limit. And if I have a limit that can be defined in Fastify, I'm good. I don't need much, to be honest. So there is body limit. Okay, so here I'm just adding add more Fastify options to the server block. As an example, body limit is missing. This is enhancement and a good first issue. Okay, great. We don't need to do any work. Super happy. Okay. Amazing. Amazing. So we don't need to do this. So this project is done. Almost. Almost. Almost done. I still want to make it scalable, right? So this is not need to be done. Okay, so we've done all the to-dos. Okay. Completed. Why you need to trace the request ID in the database, Tallevo? All to-dos. Completed all README. Okay. Okay. So it is the gist that I want to achieve, okay? I want to make this scalable and use Postgres for my storage. Now, very recently, I was reading an article on distributed system, and it was actually very interesting because there is a so in order for the queue. Okay, let's talk a little bit about what is the problem of making something like this into plus Escalidro. Okay, so what is the problem that we need to solve? Okay. No, we don't. But I don't know if this is something that we should be worrying about. But you could put the request ID in the database yourself. Like in the queue, when you create a message, you can put all the headers on it. So you can put some headers. So you could put your request ID of that you want to send in there, so it's transmitted down. So yes, technically it can be put inside the headers. It's not a different field. It is a scalable queue system. Okay, so this is what we did last time, and seems pretty cool, right? However, this has a SQLite. Okay, now this works because this is just one server, right? If we want to make it the a little bit more safe, what we need to do is, instead of using SQLite, okay, so I'm going to call this is not the unscalable queue system, but I'm going to call it the outbox because that's the name of the pattern and it seems pretty cool. Okay, so instead of using SQLite, okay, we are putting this outside. Okay, and this is what's hard because we are putting this on a Postgres. And here, okay. Okay, so here the retries goes into the database too. Okay, so it is a problem. The problem is these wait until time pass. Because, if I have multiple servers running on Postgres, how can we how can we define what who needs to wait and who is running stuff? Yeah, Excalibur is super easy. Like I love it. I really love it. I prefer it way more than other tools, especially if I'm just drawing for myself. Either that, or I am just using the Moleskine app on my iPad. If I need to collaborate with others, Miro is probably better, but it produces less nicer diagram from my point of view. So if I could get this style in Miro, but I don't know, Miro is less nice. So the problem with this approach is that we need to elect a leader. And this is kind of a freaking problem, okay? So let me add a library. What are we doing? Currently, we are implementing the Unscalable Queue System, which is currently unscalable. It cannot scale to more than one node, and we are working to make it scalable. And how can we do that? That's what we're doing. And I'm picking a sticky, okay, here, and what I'm writing inside the sticky is we need an election to elect a leader. I'm not going to use the sticky. And I'm just putting it into a box. That is no fill. Yes, lock on DB. Yes, that's what I want to do. We need to elect a leader. And if we need to elect a leader, we need to, how can we do that? Okay. I've seen that there is a feature in Postgres that I've never used that I wanted to try it out, which is called advisory locks. And with an advisory lock, I can take control. I can get a process locked, and that process become my master, my leader. Sorry, not the master. Sorry. And this is called the bully election algorithm. Bully algorithm. Okay. So is basically, get something. The first one that gets, it's an adaptation of this. And it just says, well, who has the highest process number, who can grab the handle of this, it just gets it. Okay. And essentially it's just a bully. And I'm going to implement a bully. Doesn't sound nice, but it's what it is. So it's a variation of the bully algorithm. And seems cool, right? Oh, sorry. If I can grab the handle, it's so essentially let's draw this. Okay. So let's say that I have, this is A. Sorry, and it probably needs smaller boxes. So this is, and I need the green. Okay. This is A. We have 3 peers. B. And I want them in, okay. And then I have C. And I am making this orange. Okay. Now, and then I have my database. Okay, where I have my database. Okay. So each 3 of them will drop a message to my database, and which is acquire lock. Oh, sorry. I need this, and I need, like, all 3 of them will do this. And I want, okay. And then I have the last one. Ooh. Okay, all 3 of them are trying to acquire the lock, and only one succeeds. So this says, oh, ooh, what have you done? Okay. And the others don't get the same response. So fail. No, I am actually electing. So the there are 2 problems here. It's not just a lock on the, it's a lock to be the leader and process messages. Like, it will I'm just going to elect the leader, and the leader will actually will do all the sending. There won't be any. The other processes are just there for replication, essentially. To be honest, I think this is more than sufficient for most use case, because we need probably more servers to provide scalability and redundancy, but we don't need more than one search sending out data, mainly because look, Undici can send. Yes, but the the gist, yes, absolutely. It's not it's redundancy, not a horizontal scale, but it will allow me to create multiple instances so that all of them can receive the saving part of my messages, and one of them will be elected to run as the leader and send the data out. And all things considered, look, it's before you, like, the amount of bandwidth that you need to saturate your network card is to send data out is actually pretty steep. And with something like Undici, you could actually push it down out to quite high numbers. So I'm not like super concerned about just selecting a leader. Okay. It's scalable in the sense that you will be able to scale it to multiple nodes. Okay. And it will elect a leader and keep going, but it would work. Technically, once you have elected a leader, it could tell to another peer, go send that request. But truth is, what's needed. Okay, so this is my bits. Okay, so what we can do is we can create a make dear bully, and let's do a little bit of an experiment so that I just so we can just get it done in an easy way. So which probably is the only bits that we can do today. The checkout-b bully, okay, and that's me. Okay, so we have the bully and make dear bully POC. Okay, so cd bully POC. Okay, so npm I at databases pg. We already have this installed. I just want to make sure that everything is there. Okay, so here this is the call. Let's call it the bully, and let's try. So first of all, okay, now let's just do an mjs file. So vim bully.mjs. Okay. Okay, there's cool. So here we just know import. Don't remember how to use this library. So at databases. Let me check. So lock MySQL. It only, I don't know if there is like types of locks. MySQL. I don't think it's locking. I don't think that has what I'm planning to use is Postgres advisory lock, which seems great. Okay, like advisory locks. Basically, you just lock something, okay, and that's it. And there are, yeah. Yeah, I don't know if there is for MySQL, but right now we are dealing with Postgres, so I'm good. Let me see. So we need to connect with Postgres, and I don't remember how to do that. So getting started. Okay. Oh, okay. Yeah. Yeah, I want this bit of code. Okay. So okay, and okay, and this is probably not correct, so I'm just going to just drop this and just drop this and see what it's going to do for me. So oh yeah, oh, connection refused. Ooh, I'm not running Postgres. Very weird that I'm not running Postgres on this machine. So where is it? Oh, I am not. Oh, great. Okay, I'm not. Amazing. So, okay, so what I can do, I can go and copy the platformatic, no, cp dot platformatic, docker compose dot apple silicon here. Now, why I need docker compose for apple silicon and one for everything else, I still don't understand this completely. So I'm okay. I'm just removing everything, just keeping the I need this ARM64V. I don't have a clue. Okay. So cool. So docker compose dash f up. Oh, docker ps. I know I have it running. Okay. Sorry. Let me just see where the heck is it. I don't know where it is. I've lost it. Oh yeah, found it. Okay. Well, I've stopped it now, so I can actually start mine. Here we go. It's up. Okay. So here I need probably to put admin Postgres at localhost. Let's see if this works. Didn't work. Oh yeah. Yay. Okay. Now it out failed. Okay. So let me see what the password for that thing is. So cd platformatic vim packages SQL mapper test helper. Oh, Postgres. Whatever. I'm going to go to swear a bad word here. Postgres, and then here is Postgres. Okay, look, it's so much fantasy for a database name. Cool, okay. This is working, okay. So, okay. So here, what I can try is look at this. Let's look at this doc. Okay, so here we have the docs for the advisory lock. So here it's session level lock. Yeah, I want the try advisory lock. Okay. Oh, what's a shared advisory lock? Sorry. It does not. We thought that shared lock of the same resource only with exclusive locks. Yeah. Okay. So I want an exclusive locks, and they want the try method. So try advisory lock. Okay. Here we want. Okay. Okay. And I'm going to put 42. Need to put a big int number here. So result true. Okay. So here, instead of waiting on the connection, I am going to set timeout. Going to do import set timeout as sleep from time as promises. Okay. So I wait sleep 10,000. Okay. So if I run this node bully, time out. Okay. If I do that and then I run it again, it returns false. Amazing. Okay. Amazing. And if I stop and run it again, it returns true. And amazing. Okay. So basically, it tries to acquire the lock, and if it dies, if the session dies, it's dead. So he's gone. Seems perfect. Seems exactly what we need. Exactly that. So basically, the algorithm is take the lock. Once we have taken the lock, we can run as before. Okay. Yeah, the lock is at DB level. Yes, that's what they are. Not DB, I think it's schema. Let me check. Yeah, it's an identifier. It's a resource identifier, which is a 64 key bit or 32 key bit. Yeah, I think it's at database level. Let me try, okay? So if I connect to, does it work? I need to create ABC. Yeah, it doesn't work. Okay. Okay, so let's create that. PG. No. And what's the name of this command? I never remember it. PSQL, PLSQL, PL. I can never remember. Connect to Postgres command line. What is K1 and K2? I have no idea. It's not written anywhere. I'm just using one. I think it's so. I think this is if you use integers versus a big integer. Yeah. PSQL. Okay. PSQL. PSQL. this is not working. So PostgreSQL PSQL -- help. -host. Oh yeah, the username, password. Where is it? I need. Where is it? Username. See password. Okay. -u Postgres -w. Ah. Oh, why didn't? Oh, -w. Okay. Ah, didn't connect it because I need the host. And oh, didn't work because it's Postgres. Come on. Postgres. Okay, amazing. Okay, so here create database ABC, and then create database BC DEF. Okay, created two databases. Okay, so in the first one we are connected with the first bully, and DEF we are connecting with the second bully, and they both. Okay, so it's the database level. Great. So this works as I would expect. Cool. Perfect. Works great. Pretty great. So I need to migrate everything to Postgres, and then I need to migrate everything to Postgres, and that will be it. And then when it starts, and every, I don't know, 10, 30 seconds or something, check if there is a master and see if there is a leader and grab that. Yeah. Seems great. Seems a great approach to elect a leader if you have a database. You can use, by the way, you can use Redis too if you have a Redis available. But given that we need that SQL database anyway, then this is great. I love this. But we probably won't have much time because I have more or less 10 more minutes to go before I am down to... Oh, which number do you use? Random. No, I cannot use a random number here because I must use the... because I must, so I cannot use random because I must use, I need to use the same number everywhere for each one of my queue, of my outbox or my outboxes. So all the process needs to use the same number, essentially. Yeah. Unless, let me see. Well, yes, because I need to elect one runner, right? I need to elect one leader, not multiple leaders. So, yeah, one at a time. Yes, exactly. Why not the same every time? I don't understand. Well, because I want to have only one leader elected at any given time. So if I want to have a leader elected and a leader at a given time, all the processes need to use the same identifier for the advisory lock. Otherwise, how would it work if I change it? If we wanted to scale this to multiple processes, okay, which each one executing calls and stuff, what we would do is we would elect multiple. Essentially, each one would try to take a lock on the queue or something, and then that will be it. Or you could use the queue ID with as the lock, so I can only handle that queue. But look, I think this will be fine if it's the same everywhere. No, not random at process start. I would just put it as a config value or cable it and as 42. Or let's do something very cool. So let's do so outbox for let n 0 for char of outbox const c of outbox console log n 673. This is perfect. I love this. So this is here, it's n. Cool. Yeah, perfect. It's not random, but it's 673. Yeah, outbox chars, characters char coded summed up. Seems great. This seems a phenomenal algorithm. I love it. Cool. Okay, I am going to commit this, and I need to go and feed my daughter. So I'm not going to, as I said beginning, I am going to not stream this Thursday, so we'll probably resume this work next Monday. I'm traveling this Thursday. I will be yeah, I cannot share what I will be doing, so I'm so sorry. But some surprise for Platformatic, okay? So yeah. So Tallevo, yes, exactly. So you identify different numbers to identify different stuff. So okay, let me try something different, okay? So here I just want to verify something, okay? So let's do while true, okay? And I'm just doing an await. Okay, here. So I'm going to run this, okay? And this is my bully. This is my second bully. Node, oh, CD bully, node bully. Okay, one is the bully, the other one is not the leader. If I kill the first one, the second one becomes the leader immediately. It's perfect. I just need to poll constantly this thing, and it will tell me exactly where if I am the leader or not. Great. It's totally great. Let me see something here. What are the managing connections? Yeah. The lock is acquired at startup or at at polling time. So we'll need to run the query every 30 seconds or something to get the lock, essentially, and become the leader. The leader. Yay! Works. It's the stupidest algorithm for implementing an election system, but it get my job done, and we can move it and be this being a production ready system running Postgres, which seems pretty cool, right? Yeah, we'll probably finish this next time, but I'm pretty solid about this. Seems simple enough and scalable, well, to a point, but look, it's before you exhaust the resources of sending data from one node, it will need to. Oh yeah, let's try that. Okay, so we probably need to console log the PID. Okay, so process PID. Okay, so this is my bully, and then I am killing the bully. Sorry about this. Yeah, and then the other becomes true. It's amazing. It worked. It's the simple possible election system that you could manage. Yeah, cool, right? I can call this distributed system for dummies, to be honest. This is so nice. And we could probably implement this with top of Redis too. So it's pretty simple and straightforward. So yeah, it's great. So we elect the leader, run all our bits, and then that's just works. And it gets my startup out of the hook so that we have queues and crowns and everything. Good luck in saturating this. So pretty happy. This is a good session. So yay. Yes, so we are probably going to continue with this next Monday, which I think was pretty nice and cool. So hi. Hi Eliphas. We were just shutting it down. So I'm glad you joined, but POC working. Okay. Oh. Yeah. Get push. This is just a draft thing, and we are going to open the PR so that you could just check it out. Here we go. And so that you could check it out. Make it run on more than one node. Fixes. Make it scalable. Okay. And this is a draft PR. Okay, let's write a little bit of a description. This first. This does not have much inside right now. There is just a Boolean election algorithm using PostgreSQL advisory locks. And here we go. Cool. Seems nice. Oh, somebody did the first contribution with Fastify today. Whoa, amazing. Let's see. Let's see it immediately. Yay, okay. Cool, thank you. And yeah, seems perfect. Approve. Congratulations. LGTM. And yeah. They're still waiting for Fraser to get his review, but once it we'll land it. Well, I think it's resolved, right? Sorry. Yeah. Cool. And yeah, let's do Ptal. Amazing. Thank you for contributing. It's amazing. Cool, folks. Thank you so much for joining up. I'm so glad that a lot of people joined and saw the stream, and stay tuned. I will be streaming back next Monday. I'm traveling next Thursday, so and it's amazing. Thank you very much, and see you soon. Bye bye. And we are stopping the stream.